going to talk about a source of energy that's more abundant than all the other energy sources combined, but we're not currently making good use of it. And I start by talking about electricity. So we're at a very interesting time for electricity right now. Demand is increasing at an incredibly fast rate. One of the reasons for this is because we're using electricity as a clean way to replace things we formerly used fossil fuels for. So for example, our gasoline-powered cars are being replaced with electric vehicles. Industry's doing a similar thing. So we're seeing at steel mills, for example, their coal-fired furnaces are being replaced with electric arc furnaces. And then we're seeing in the news, data centers, AI, all these things are very hungry for electricity. So right now we need sources of electricity that are reliable, clean, but also quick to build, quick to bring online so we can address this increasing demand right now. So what are the energy sources we use for electricity right now? And they all have their pros and cons. So we have the fossil fuels, coal, natural gas. They're reliable, they're robust, but they have pollution. They come with pollution. Natural gas has an interesting advantage as well because it's quick to build, it's quick to bring online. So to meet the demand right now, we're actually seeing them bring back online a lot of natural gas. Then we have the big ones, right? So the hydro and the nuclear, and they're big, clean, reliable. But because they're so big, they tend to take a long time to build and bring online. Then we have solar and wind, which are fantastic when the sun is shining, when the wind is blowing, but we tend to need extra infrastructure, storage, batteries, things like that to make sure they're a reliable source of electricity. Okay, so what's the energy source I haven't mentioned yet, the one I want to talk about today? It's actually so common, I can guarantee you saw some of it today in some form. So what is it? It's waste heat. Waste heat. Okay, so what is waste heat? How come I can say you saw some of it today? You probably saw a gasoline-powered car, and coming out of its exhaust, actually, that's very hot. So actually, a lot of what's coming out of there is waste heat. There's thermal energy being dumped out that exhaust. More commonly where we see it is industrial facilities, right? So they have these chimney stacks that you see when you pass them on the highway, and what's coming out of there is very hot as well. So they're dumping a lot of energy. They're dumping waste heat. Okay, so how come I can say it's more abundant than all the other energy sources? Well, scientists have calculated that 70% of the energy we consume globally is lost as waste heat. 70%. Okay, that is a massive, massive amount of energy that's available. To put this another way, if you're using an energy source to make something useful like electricity, so say you start with 3 megawatts of diesel fuel, run that through your diesel engine, you will end up with 1 megawatt of electricity. 2 megawatts of that energy is dumped, is discarded as waste heat. 2/3 of the energy that we use is dumped. Now you might be thinking, okay, well, they're dumping it, so it's not valuable anymore, right? That must be the case. That's actually not true at all. And to emphasize this, I want to talk about some work that we've been doing. So we've been going to industrial facilities and measuring how much waste heat they have, okay? So I'll talk about a steel mill that we worked at, and we looked at just one single chimney stack for a single furnace, okay? And we measured that the heat that they're dumping reaches 800 degrees Celsius. 800 degrees Celsius, okay? To put that in context for you, the nuclear generating stations in Ontario, when they heat up their steam for steam power, generally the max temperature that steam will reach is 300 degrees Celsius. So 800 is an incredible, incredible amount of heat. Now, how much of it is there? So again, this single stack at this steel mill for a single furnace, okay? We measured there are 5 megawatts of thermal energy being dumped out that stack, okay? So we have technologies that can convert about 20% of that into electricity. So we can make a megawatt worth of electricity from that, which is enough to power 800 homes continuously. 800 homes. Not only that, there's a beautiful synergy here because these industrial facilities that have all this waste heat available are also the places that use most of the electricity. So there's a harmony built into this already. Okay, so at this point you're maybe thinking, what is going on? Why aren't we using this? What's up with this opportunity? Why aren't we making use of this? This is crazy, right? There's really sort of two answers to that. Firstly, it's distributed, right? So we're not very good with things that are very spread out. So all these different facilities have all their waste heat and it's very spread out. And the second thing is the technology that we use to convert heat to electricity. So what are these technologies? We tend to use things like steam turbine technologies and similar technologies. And they need to be very big to be efficient. And they need to be huge to be economically viable. So what we do right now is we'll have big, centralized, massive generating stations that have all the heat in one place, right? You have a massive steam turbine there, okay? You make all the electricity in one spot and then send it out wherever it needs to go, across the province, across the country, wherever it's needed. But what we need are technologies that are scalable, that are efficient at small scales, so they can be installed at all these places where there's incredible amounts of energy locally, make the electricity there, and then send it where it's needed. This is where my background comes in. So I'm a professor of mechanical engineering at Ontario Tech University and an entrepreneur, and I've been researching and developing technologies that can address this, that can look at sustainable energy use. One of these is we've re-engineered the Stirling engine. It's an example of a technology that is scalable, clean, quick to bring online. And there's other technologies out there that can similarly address this issue. So one reason I'm giving this talk is to bring focus to this, to bring more attention to this, so we can develop these technologies and take advantage of this incredible opportunity. And there's one more thing I want to say before finishing off here. And it's important because it's something we can all do, a way we can contribute. So these industrial facilities are actually reluctant to use their waste heat. And you might think, why is that? It can save them so much money, they can make such clean electricity. Well, it turns out that when you pull that heat out of the exhaust, okay, most of what's going up there is water vapor, okay? So if you take the heat out of it, as it exits the stack, it becomes visible clouds right away. And so the perception is, by the neighbors, by the people passing by, that there's more pollution there. But there's not more pollution, it's just more visible. You're just seeing the water vapor form clouds. So one thing I want to say to us is, let's change this perception. Let's view this in the future as a positive thing rather than a negative thing moving forward. And that's an important contribution that we can make. So we have an incredible opportunity here for an abundant energy source that is waste heat. And with it, we can make electricity that's reliable, quick to bring online, saves a lot of money, and is sustainable. Thank you very much.